Hello and welcome to my channel. In this video we will solve problem 1 and 2 of exercise 14.2 in 11th class maths. The first problem is, which of the following cannot be valid assignment of probabilities for outcomes of sample space S equal to set omega 1, omega 2, omega 3, omega 4, omega 5, omega 6, omega 7. Assignment is given as this. Okay, so we are given a sample space and the outcomes are given. 7 outcomes are there here, and then the assignments are given which are varying. Okay, so the first assignment is A here, right? Second assignment is B, so like that. The fifth assignment is this E. So we have to tell whether these assignments A to E are valid assignments of probabilities or not. Okay, so let us see how to solve this. So solution, A1 let us take. So omega 1 is given omega 2, omega 3, omega 4, omega 5, omega 6, omega 7. So omega 1 is 0.1, then 0.01, then 0.05, then 0.03, then 0.01, then 0.2 and 0.6. okay, so now we can see that this omega 1, which is 0.1, is less than or equal to 0 and less than or equal to 1. Okay, so that means the probability of omega 1 is 0.1. so this 0.1 is between 0 and 1, right? So now we can write P of omega 1 is equal to 0.1 less than or equal to 0. And similarly, if we have probability of omega 2, it is what? 0.01, so which is less than or equal to 0, less than or equal to 1. So similarly, we have 0 less than or equal to probability of omega 3, which is 0.05, which is less than or equal to 1. So similarly, we will have 0 less than or equal to this 0.03 less than or equal to 1. And similarly 0 is less than or equal to 0.5 and 0.01 less than or equal to 1. okay, then 0 is less than or equal to 0.2 less than or equal to 1, then 0 is less than or equal to 0.6, which is less than or equal to 1, right? So we find that all the probabilities of the outcomes are greater than 0, less than 1, right? Now we will check the sum of all the probabilities. It should be 1, right? So now omega 1 plus omega 2 plus omega 3 plus omega 4 plus omega 5 plus omega 6 plus omega 7. So this is equal to 0.1 plus 0.01 plus 0.05 plus 0.03 plus 0.01 plus 0.2 plus 0.6. okay, so let us take the sum. Here we will take 0.1, 0.01, 0.05, 0.03, 0.01, then 0.2, 0.6. okay, so 1 plus 1 is 6, 6 plus 3 is 9, 9 plus 1 is 10, 1 borrowed, 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 6 is 10, and then 1 here, and so point. So we get 1, right? So the sum of all the probabilities, this here it is P, right? So sum of all the probabilities is 1, right here. So this is a valid assignment. So therefore A is a valid assignment. Of probabilities. Okay. Then let us look at B. So this is B, right? So that means if we look at omega, probability of omega 1, it is equal to 1 by 7, which is less than or equal to 1. And similarly probability of omega 2, which is also 1 by 7, less than or equal to 1, right? So all these are same, less than 0, less than or equal to probability of omega 7, that is equal to 1 by 7, less than or equal to 1. Okay. Now let us look at this sum. So now if you look at this sum, probability of omega 1 plus probability of omega 2 plus probability of omega 3 plus probability of omega 4 plus probability of omega 5 plus probability of omega 6 plus probability of omega 7. Okay. So this is equal to 1 by 7 plus 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 1 by 7 and plus 1 by 7. Okay. So this is equal to what? So 1 2 3 4 5 6 7. So 7 times 1 by 7 is there. So 7 times 1 by 7, which is equal to 1, right? So we have that all the probabilities are between 0 and 1, and the sum of all the probabilities is 1. So therefore B is a valid assignment of probabilities. Okay. Of probabilities, valid assignment of probabilities. Okay. So now let us look at this C. So C is what this. So it is so let us check if the probabilities are between 0 and 1. So 0 is less than or equal to 0.1, less than or equal to 1. Then 0 is less than or equal to 0.2, right? Here, less than or equal to 1. Then 0 is less than or equal to 0.3, which is less than or equal to 1. Then 0 is less than or equal to 0.4, which is less than or equal to 1, right? Then 0 is less than or equal to 0.5, which is less than or equal to 1. Then 0 is less than or equal to 0.6, which is less than or equal to 1. And 0 is less than or equal to 0.7, which is less than or equal to 1. Okay. So this is what we have, right? Now we will, so all the probabilities are between 0 and 1. So now we have to look at the sum of all the probabilities. So that means 0.1 plus 0.2 plus 0.3 plus 0.4 plus 0.5 plus 0.6 plus 0.7. Okay. So this is equal to, let us check. So we will add, here only we can add 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 15 plus 6 is 21, 21 plus 7 is 28. Okay. Then 2 here and point. So what we get is 2.8, right? which is not equal to 1. So therefore this C is not a valid assignment, because valid assignment should satisfy both the conditions. All the probabilities should be 0 to 1 and the sum of all the probabilities should be equal to 1. So the second condition is not satisfying. So C, C is not valid assignment. Okay, is not valid assignment. Okay, so now let us go to the D question. So in D you can see that there is a negative number here. Okay, so it definitely is not a valid assignment. So we can write probability of omega 1, which is equal to 0.1, is less than or equal to 0. So the first condition won't be satisfied. All the probabilities are not between 0 and 1, right? You found a probability that is less than 0. So what we can say is D is not valid assignment. Okay, right? So now E, let us see. E is this. So if you look at this here, the probability of omega 7 is 15 by 14, which is greater than 1, right? See, you can say this is greater than 1. Why? Because the numerator is greater than the denominator. So definitely 15 by 14 is greater than 1. So probability of omega 7 is equal to 15 by 14, which is greater than 1, right? So now the the first condition itself is not satisfying. All the probabilities are not between 0 and 1. So therefore E is not a valid assignment. Okay, okay, now let us look at the problem 2. Which is here. A coin is tossed twice. What is the probability that at least one tail occurs? Okay, so what we have to do is, it is given that coin is tossed twice. What is the probability that at least one tail occurs? So let us look at the sample space first. Now the random experiment is what? A coin is tossed twice, right? So a coin is tossed twice, right? So the sample space will be this: head, 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 tail, tail, head, and tail, tail, right? Now all these outcomes are equally likely outcomes, and the probability of each outcome is what? 1 by 4, right? So here all outcomes of S are equally likely. Okay, are equally likely. That is, the probability of each outcome here is equal to 1 by 4, right? So omega I belongs to the sample space. So for each outcome, the probability of the outcome is 1 by 4. Now what we have to take event is this, right? At least one tail occurs. So that we will call as some event. Let E be equal to the event that at least one tail occurs. Okay, at least one tail occurs. So that means you know that number of elements in E will be what? So for that we have to write the event E in terms of set form, set build roster form. So E is equal to what? At least one tail should occur, so it will contain HT because one tail occurs here, then TH, again one tail occurs, and here two tail occurs. Okay, so this will be the event E, right? Now what will be the probability of E? So probability of E will be equal to nothing but number of elements in E divided by number of elements in S, right? This we have learnt. So what are the number of elements in E? How many are there? 3. And what are the how many elements are there in S? 4, right? So 3 by 4 is the answer. All right, so that is the solution of problem 2. So that's it in the video. If you have liked the video, please hit the like button. If you have not subscribed my channel, please do subscribe. I will see you in the next video.